We're now going to learn how to find the derivative of the natural exponential function. We're going to start by looking at the graph of the natural exponential function. Here's the graph. The derivative of the natural exponential function is fairly easy to find because the slope of the function at the point x is equal to 0 is equal to 1. E to the x is the only exponential function with a slope of 1 at the point x is equal to 0. And that's why when you're studying calculus, you always start by finding the derivative of this particular exponential function. To find the derivative of f of x is equal to e to the x, we actually need to start with the limit definition of the derivative. That definition is f prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x, all divided by h. In our next step, what we're going to do is wherever we have an x in the function, right here, we are going to replace that with x plus h. Let's see what this gives us. This is the limit as h goes to 0 of e to the x plus h minus f of x, which is just e to the x, all divided by h. Now we're just going to do a little simplification. Notice that we can rewrite e to the x plus h as e to the x times e to the h. That just kind of breaks it up. So this is the limit as h goes to 0, e to the x times e to the h minus e to the x, all divided by h. Now, each term in our numerator has an e to the x, so we can simplify it and pull that out. So we'll write this as the limit as h goes to 0, e to the x, and then we're left with e to the h minus 1, all divided by h. Now what we're going to do is take our e to the x and pull it outside the limit because it doesn't have an h with it. So this is e to the x times the limit as h goes to 0 of e to the h minus 1 all over h. Now what we're going to do is we're going to look back up to this line right there. What we have here is the same as what we have here if x were equal to 0, because e to the 0 is equal to 1. So this tells us that our derivative at 0 is our limit as h goes to 0 of e to the h minus 1 all over h. We're just plugging in that x is equal to 0. And notice that our left-hand side was f prime at x. So now we had f prime at 0. Now we can take this and plug it back in down here. And we're going to write this as e to the x times f prime at 0. Now what we have to do is go back up and look at our graph. The derivative of our function at 0 is the slope at 0, and that's equal to 1. So going back down again, we can say that f prime of 0 is 1, so our derivative is just e to the x. I think anyone that studies calculus needs to see that derivation. We can now say that the derivative of the natural exponential function e to the x is just e to the x.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.